In this problem, we will design a single bolted double cover butt joint to connect boiler plates. Okay, the boiler plates are 12 mm thick, and we are asked to design using M16 bolts of grade 4.6. The grade of the boiler plates is 410. Now, in longitudinal section, when we see, so this is the boiler plate. They're overlapping, and we are told many single bolts. So like this, one line of bolts. If you see the cross section of the boiler, it is subjected to pressure from inside, and it's like this. Okay, so this is our force. Design in this case means that we are supposed to find out the pitch. That means the center to center distance between the holes. Okay, so the nominal dia is given as 16 mm. The dia of the hole will be 18 mm. FUB is 400 Newton per mm square for 4.6 grade. For the plate, the ultimate strength is 410 MPa, and the thickness is given as 12 mm. Since it is a double cover butt joint, the bolts are in double shear. So one section at the shank and one section at the threaded portion. So NN and NS both are equal to 1. So the nominal strength we calculate is, this is only a one bolt that we are calculating in shear, substituting the values in the equation for nominal shear. We get 82651 Newton. Therefore, the design strength in shear is 66121 Newton. In the previous problems, if you have noticed, whenever we have calculated the design strength in shear and design strength in bearing, we have always got the design strength in shear to be lesser as compared to the design strength in bearing. So we could assume that bearing strength is more than shear strength. So the design criteria for pitch will depend upon the strength of the shear. Of course, later in the problem, we will also have to find out whether check whether this assumption that we have made is right or wrong. So to get the maximum efficiency, the strength of the plate per pitch width should be equal to the strength of the bolt. Now, the strength of the plate per pitch width is given by 0.9 into 410 into the pitch minus 18, 1.25. This has to be multiplied by the thickness. So in this, what we have done here is, we are considering one width like this. Okay, so we know that this is the pitch between the center points of the bolts, and when designing we take from halfway width between the two bolts. Okay, so this is also equal to P. Now, so we have taken the pitch minus this bolt hole, that is 18 mm. That is why we have substituted this here. This is nothing but the area of the plate. So it is the pitch minus 18 into the thickness. And when we solve for this in terms of P, we get P minus 18. So now what we have to do is we have to equate these two equations. So this is A and let us call this B. To find out the pitch, let us equate the strength of the plate and the strength of the bolt. So we have 3542.4 into P minus 18 equals to 66121. So from here we get the pitch as 36.67 mm. We know that the minimum pitch is given by 2.5 times the nominal dia, so this is 40 mm. Let us provide bolts at a pitch of 40 mm. Let us check for strength of bolt in bearing. Now we know that KB is the minimum among E by 3D0 or P upon 3D0 minus 0.25 FUB by FU and 1. E value is not given to us, or let us assume that the E value is sufficient. So KB is 0.4907, minimum of these three, and therefore the design strength of bolt in bearing is 2.5 into 0.4907 into 16 into 12 into 400. I am not finding out the nominal strength first, I am directly finding out the design strength. Therefore, I am dividing it by the partial safety factor of 1.25. This is 75372 Newton, which is greater than the design shear strength. So the assumption that we made about bearing strength of the bolt being greater than the shear strength of the bolt was right. Since the pitch which we have provided is slightly more than that was required from the strength consideration of the plate, the strength of the plate is more than the strength of the bolt. Okay, so we can say that the design strength of joint per 40 mm width is 66121 Newton. This solves the first part of the problem, where we were asked to find out, to design or to find out the pitch of the bolts. Next, we are also asked to find out the efficiency of the joint. Here we are going to first find out the design strength of solid plate per 40 mm. This is not 400, sorry, this is 40 mm. 40 mm width is equal to Fy, which is 250. Now this is only the solid plate without considering the bolt hole. So for we had a diagram something like this, right? So we need to find out the area. So the area would be this 40 multiplied by the thickness, which is 12, divided by 1.1. 109091 Newton. And next we have to find out the maximum efficiency of the joint, which will be given as the design strength of the joint upon the design strength of the solid plate multiplied by 100. So the efficiency of the joint is 60.61%. So this solves the second part of the problem. Thank you.